Hello everyone, welcome to episode 2 about player tracker. So this is the root project here, the Florian project I showed last episode. See some changes here, right? There's a couple of new folders here, player tracker, data analysis. So everything we went over last video is all here in data analysis. So this is the stats here, get match where we got the ID and we put that ID into the heat map and we created the heat map for the game. Everything new is elsewhere. So one thing I want to kind of highlight is virtual environment. That's in the Vend. It's very important if you're doing any project because sometimes tools need a specific version of, let's say, Python, because it's the language we're working on. Some tools work only or better on certain versions of Python, but you don't want to have conflicting versions, right? If something might be a little older, it maybe can't handle a newer version of Python, that could be a problem. So having a virtual environment, make sure A, your project's always going to work in that environment, and B, it helps make sure that your mindset of transporting and packaging. Right now, I don't have anything set up. I just have a basic virtual environment. I don't use Poetry, which I know a lot of people like to use. This is just personal projects. However, I might start thinking about using other machines, and you'll learn why actually as I go on about this project. So I want to open up player tracker, and you can see all our new files here, and there's even a new folder here, model training. Yes, we're training a model. Nothing too deep about that. So to give you an idea of what the player tracker part of this project is, what that folder entails. So big picture idea, the best case scenario is I want to create a live data analysis project while watching a game. So I want to have a live statistical analysis while a game's going on. So I want to just, I think it's really cool and really nice when they have, possession, blah, blah, blah. But when they have in the game, you see, it's 60-40, okay, that's cool. I think it's really cool to look at the data while the game's playing on and maybe understand. But also we can individualize statistics, right? If I can track every single player, not only can I get a team, but I can get that individual statistics. I can create, just basically automize and get my own number. Sometimes I don't necessarily trust anything from outsource, especially if they might have the same success rate. Maybe they don't care. Or they might be using human tracking, which can have errors, right? If someone misses failed pass, that's kind of it. Right, so this is really nice because if he's having, this is the idea for Florian Wirtz. If he's having moments of brilliance or moments of bad, I want to know why, and I want to help see the data to help better understand and help maybe develop a better way to track his player performance and what are the settings, what is the data, what are the numbers to help him that explain why he's doing the best when he's doing the best, but also what's worse, right? This kind of overall arcing mindset of this entire project is I want to think about, so this is an overall mindset during the entire project is I want to see his highlights and his lowlights, see exactly what moments he's doing better, what moments he's doing worse, and then understand why. But also, I don't think you can ever capture a great picture of a player if you're just looking at highlights, because those are subjective moments that someone chooses to display and they choose to not display others, and sometimes they can be misleading, and some players are just better highlight players. Is Florian Wirtz one of those players? I guess we'll find out, right? That's the idea of this project, is to see when he's struggling, when he's doing his best. So doing that while watching a game, I think, would be the best way, honestly. So this isn't fully built up. I would say this is kind of the minimal project to kind of get going here. This is model training. I just did a basic training on a model. And so I'm going to have all the files here. So it's runner, tracker, video processor, and setup. Those are the main ones for the player tracker. These are the main ones to pay attention. These are the only ones that are actually running when I'm running my player tracker. And what file actually runs the player tracker, but runner here. So you can see we're importing a lot from the other 3 mentioned files. So this is connecting the tracker to the actual video processor to the setup. So the idea of how I actually have this running is right now, I want to ideally set it up so that I can just watch a game on my screen and on the data analysis at the same time. And I can pull that up whenever I choose to. So I have it set up that my left side of the screen is actually getting recorded. It's just running the screen recording, and we split up the screen recording frame by frame. We send that to the video processor. So your processor gets each frame, processes it to make it easier for the tracker to actually track the model. And before the video processor and tracker actually work, I have a setup to make sure everything that would need to be done. So we have a setup to make sure that everything needs to be done before I actually want the model to kind of go loose and to collect data is done. So limiting it to actually players around the field and limiting what we're showing. That's the main idea of setup. But here in the runner, you can kind of see it's connected. So the queue is max size 15, which means that only 15 frames can be in the queue before it starts dropping. I just don't want the queue to get super backed up because that could 100% be a problem. And if we have to miss a frame here and there, it's not the end of the world for us. OB model. So this is our model that we're from. It's a YOLO model, and that's provided by Ultralytics here. YOLO actually stands for you only look once, and that is kind of industry standard. Just in the past few years I've seen it's basically YOLO is for object detection. I've seen a lot. I've actually worked with it beforehand, so I'm also familiar with it. And what it does is it draws bounding boxes around objects that it detects as something, and then it'll give you an ID or whatnot. It gives you can get that data from that detection, understand what it thinks it is, why it thinks it's that, numerically. Task there is to detect. And so you see here, best OpenVINO model. Some people who probably have worked with YOLO before don't quite understand what that means. So the best part is, again, from training, the best model that I trained is going to be under the best model. And OpenVINO is actually kind of unique here, and definitely is localized to this machine. So if part of the mindset of creating an environment, I'd have to make sure I work with this. So OpenVINO actually helps with AI processes on Intel machines. So if you have Intel hardware, it works better, which is really nice that Intel has this, because Intel doesn't actually have a GPU in their machine. Like this machine right here does not have a GPU. And the GPU, if you've seen the news, you've seen NVIDIA, it's graphics processor unit, but it helps with AI, and it's so much better because it can do so many multiple tasks at the same time that CPU cannot. So it makes action and training so much easier. But again, this machine, this is just my laptop at school. That's all I have. That's just mine. So I had to find a way. So OpenVINO actually helps. I'm not actually sure statistically how much improvement it is, but anything I'm sure helps, right? I don't think it's going to make it worse. So that's why it's best OpenVINO model. It's my best trained model for OpenVINO. And then down below, this is actually where we start with the screen capture. So that's the screen recording aspect of it. And you can see we're setting up a thread for that. Multi-threading is handy because we're both recording and detecting them on the same machine in the same instance or so. So it's important that they don't conflict, or one has to wait for another. That then it would never work, right? Because it's all in the same machine. Daemon equals true. Okay, so the target screen capture is just a screen recording. Arguments frame queue. This makes sure that we just send that our queue is a max size of 15 for our frames, no more than 15. Once we get above that, we start dropping frames. Daemon equals true means that once when the thread ends, it ends that part of the project, that thread, so it doesn't keep going on forever. So blocking setup. So setup phase actually doesn't start until we make sure we have our screen captured. Because what our setup does is it takes the initial screen capture and relays what YOLO detects and helps me redefine what objects it should care about and within what bounds. And you can see that below, all within boundaries or only what selected IDs are within boundaries. That's like for the camera style. or if we want to make sure we limit it to just the people / players that are within our actual field. Because anything outside, we don't care about. I don't know, sub player, maybe we'll detect a ball boy or two. They're not affecting the play. Well, not directly, who knows. And then, yeah, after that, we just go to the old tracking model. That goes until we end that. Looking at the actual individual files, we'll go with the start. So that's the video processor here. So here in video processor, it's not too deep, right? One thing is you can see here, the left half of the screen just made there, so I can send that and it's only going to screen record that. MSS here is multi-screen shots, I believe, a multi-screen something like that. Seems about right? It's multiple screenshots is the screen recording. So that's how we use it in monitors. This just tells it, right now, I just have a single monitor, but if I connect it to another monitor, which I might try to do later, see if that helps things. Could be useful, but then we'd have to, hopefully change this. So if I want to make that expansive, see if what all that improves on, what changes to that, then I would want to use. But right now, we're just using just the monitor on this machine. This is recording, this is doing everything on this machine right now, except for training, and we'll talk about that later. And then, yeah, so while the screen capture is still going on, yeah, we only want the left half. We talked about that. That's all there. Actually, this is really cool. It's really interesting. I didn't know this. Something is CV you see here. That is computer vision. But the color underscore BGRA number 2 BGR. So all that does is actually converts BGRA values to BG or RGB, as you might know, right? And if you know RGB, those are the 3 values that go into each pixel value, from 0 to 255. The higher the number, the more of that individual color there is in that. If it's all 255, so 3 255 together, that gets you white. They're all zeros, that's black, and you can guess it through there. So BGRA is what this computer actually is using, and the A actually stands for alpha. So here it's blue, green, red, alpha. So we have to convert that so that our computer vision actually works. So that was cool. I didn't know about that at all. So working on this. And speaking of alpha, so beta is our brightness and alpha is our contrast. So you can see I'm starting off with a little bit of brightness, and our frame is what we just collected and that we just converted into the right pixel values. That's a thing apparently. And you can see this is the logic about it. It's above a 15 because that's what max Q says. We're dropping frames. And here it's just waiting to hear Q. When I press Q, it quits the screen recording and video processing. Next is setup, right? And this is kind of the biggest thing, just because it adds a lot of player tracking, but also has multiple button calls and then a little bit of UI here. So in the initialization here, we just have setting up all our boundary points that we're collecting. So on the setup screen, what you can do is you can click A where the field is. So put dots and it's like, okay, everything in here is within the field. So those are the boundary points. Maybe if you don't care about a specific area, I'm not sure, do that there too. But ideally, that's what it's for. It's something boundary complete. That's necessary just because I do points and I decide not to, or also not to complete it, not to actually do it as a bounds. Or if I do if I set points for other reasons, just if you're gonna wait until you complete a boundary before you have set up a boundary. So the idea is this is gonna be used later, especially for kind of fine tuning things. But you're gonna see it's kind of messy because I have the player IDs and I have the current confidence level, and that's a number 0 through 1. So it's kind of messy because you can see it kind of combines a lot. When we'll bunch of players together, it's kind of hard to read it. But I have that right now just to see when and why players are getting lower scores and kind of what movement and stuff. This is really good for debugging and upgrading and fixing things here. And this current sections is just all the actual IDs, right? So the X, Y, again, it's a boundary box. So you get the points and you get the width and you get the height and you get the values. You get the top left and bottom right. Boom, you're there. and setup complete. You wait until setup is complete. Once that turns true, setup goes away, and the tracker actually starts. That draw UI, very limited on the word UI because it's just remind you. So it's not just has little instructions in case I ever forget. We're gonna hop around here. Instructions are right here. So you can see left click is to add a boundary point. Right click is to close the boundary or select ID. I don't have all the logic working for actually selecting IDs if I just want to track individuals. Because I kind of just saw that while looking at it. It's like, oh, this is kind of messy. So I implemented it for now. We're going to train the model and see if that's necessary, if necessary to show confidence levels. I've just done one basic training, so nothing at all in detail, just minimal. This is all minimum right now, because that would probably take maybe a week or two more if I did some fine tuning. So definitely a goal for like next episode is have some fine tuning done to make this a little bit prettier, a little bit better. So let's go back at it. Yeah, I'm all over the place. So display the frame. So what setup has sent from our video processor. We would show the detections, show the boundary when we're doing this. So we're setting up points that creates the boundary. If it's complete, if it's complete, then we have lines that show the boundary, everything that's within the boundary, and yeah, the points of the boundary here. This seems pretty self-explanatory. If you do have any questions about anything, I'm kind of skipping over anything that's less important or kind of self-explanatory. I kind of more want to talk about decisions I made and kind of the setup. Drawing the current detections is all here, so making sure you visualize right color and our detection. So when our YOLO model sees things and it's like, okay, this is this, and it meets our confidence threshold, then we're gonna draw it here in both the setup, and then they're gonna keep it. It's gonna keep going while tracker is running. And you see here, it displays the ID. Also click for the selecting different individuals I want to actually trace. We just kind of talked about this is just the logic. If this button, and if this, then we do this. And else we just kind of add that point to the system. And we want to make sure when we click a point, it shows up too. Right button just closes the boundary. You can see that's all I have for it right now. Pointing the boundary, just seeing if it actually joins a polygon or where it is. Not super important or interesting. Run setup. Now this is basically the runner for just setup, and it has a lot of similar elements, but has like the separation setup. So there's some stuff that's basically it is copy pasta, but expanded on from our runner. So you see setup, we're gonna set up our tracking setup, we're initializing our setup right here, initializing our values. Create the window, we're gonna set the window. We're gonna listen for our mouse clicks here, and we're gonna get our frame cues, and we're gonna get. And this is still looking off of video processor. So one thing is I want to make sure I pause whatever stream or whatever source we're screen recording, just to make it easier to set up everything. I could do it while I was going, but you can see with the IDs, it's getting a little awkward. And if I want to like track only specific ones, that would be a lot harder. But yeah, so it's based off of still the running live recording. It's not like I just sent a random frame, the first frame. That could be annoying because I have to like really make sure to quickly get to whatever video I want before the image processing finalized. Run the texture model. This is important. I'm going to talk more about this in our actual tracker, and this is exactly the same thing. This is the same. Everything's the same now. And this is our model and our track, and we're giving it all the information. So this will be talked about more in tracker. If results in box ID. So we had to put together our actual track ID and what box is with that track ID with it. So our like detections, we can be like, okay, player ID 1 is this box and whatnot. So yeah, this is important of linking our ID and which box is with which ID. So we set up. And displaying the frame and whatnot. And then once when I'm done with our setup, I hit enter, then that finalizes and sends whatever relevant information to our tracker, and then tracker runs until I hit Q and I quit, and R reset in case I mess up, because nobody's perfect. So let's go to tracker, and we can talk more about that, the results. As you can see, it's here. So tracker, again, we're getting the track history. We're getting those IDs. We want to make sure that's the big thing, is persistent. If you looked back at the code when I was initializing, when you see the model persist equals true, right, and that's right here, right, persist true. We don't make sure we're keeping it up with, oh, we've seen this object before. This ID is with this object. That's one of the key things. And another key thing that helps with that is actually having a tracker model here. So that's a bot sort, which helps with things like occlusion, where an object might run into another object, especially in a game like soccer or any sports. A lot of sports will have players kind of overlap, whatever, from the camera angle. So making sure that it doesn't see this as a makeshift object. It understands when it separates. Oh, this was this object, I saw this guy. And based off of its path and trajectory, I know this is this and this object. It's going to be kind of hard for soccer, right? Because it's not like they're running in straight lines. They, ball goes somewhere, they might split off and go anywhere. But having a tracker algorithm really helps it, because otherwise we'd just have a yellow to be like player, and that's not as useful as keeping track of what each player is doing and making sure we have the same ID for each player. Class here with that is our player tracker. You'll see that later. The confidence level, our image size is 640. I think we talked about that. IOU this helps to occlude. This is the occlusion, right? So I've kind of set up high. Again, something I'm gonna fiddle with. If two players are mixed together, one thing is I don't want two players to see and they kind of like understand there's a player there, but maybe there's two and it combines them one. But that's the occlusion score right there. So going down to the results, this is pretty similar to what we've seen with our setup, but kind of understanding what that is. So results is having our track ID. So results is here. Remember, we zipped up the track ID with the actual boxes. So you see boxes there. So yeah, just get on our track IDs and setting the box now for each track ID, because we want to keep up with that, especially if there's new ones that come into play. We want to make sure we have the information for them. And we want to make sure they're in our boundary point that we set up, right? Otherwise, we don't care to display them. And so hopefully, and we're going to send, realistically, when we start adding like the data analysis into this, we're going to send those IDs, see what they're doing, and then we'll have to define movement types, and we're going to have to focus in on the ball for realistically, or a lot of like the shots, passes, and actions. Soccer actions usually involve the ball, mostly involve the ball. And then, yeah, so right now I have track ID. Realistically, it's just 90. This is the base where I was like, oh, come on. What are we doing here? It would be set to, I guess, 23. So 11 on each side plus the center referee. Maybe more. But one thing I would want to add to this is probably like Redis and do some like serious caching. There's not really much with the tracking algorithm. I have to upgrade this model right now and the tracking algorithm. So I kind of work with re-ID, and you'll see that later. Tracking history and the ID. So you see here 90. So what kind of helps with realizing the ID? So we go over to the custom bot sort. We can kind of see that's here. So our values, right? Our track type is bot sort. So track high threshold. I'm just going to go through this real quickly. You can skip if you want to. Track high threshold is the maximum threshold value to keep tracking. Or it's like if it's that or above, it keeps tracking, right? So, and below is if it drops it. So if it gets below that, it drops. New track threshold is the number actually hits to introduce a new one. And I've been mixing around all these values, so I don't know if they 100% make sense at this current build. I don't think so. I think I have it actually set up to 0.5, right? Tracker buffer. This is super high right now. Just because anything lower, and it really wasn't working well. That's how many frames it waits to see something to like re-give it its value. That's like how long it'll remember something. So the player kind of slightly goes off the screen. I have to figure out a good balance for this value, because right now it's pretty high for what it should be, but we'll see. It's kind of different if it's a single camera versus a stream we're watching. But 180. That actually translates to 6 seconds, because it's about 30 frames per second. So that's kind of similar to the IOU score we were talking about earlier. Match threshold 0.8, and it's like, oh, this is the same thing. If two scores of 0.8 within 0.8, they're probably the same. So that's like the, oh, these are matched, these are the same. With re-ID, this is the big one I'm talking about. So right now this is false just because I have to upgrade the project, but that remembered ID, so that keeps up. And this is the idea of kind of its own style of caching, but I do probably want to upgrade this to do my own like Redis, just to localize everything and cache the values, because I want to keep it to like 23. And then if a value, let's say a player comes back on screen or something, or loses a player, it can keep track of where we last saw it, and then we can guess which ID we don't currently see that it could be that isn't a value, and then we could give that player. So trying to remember players, that'll be something I want to fit and fix on. So if, if the camera pans out or whatnot, if the player just kind of falls out, we can make sure we assign them a correct index, because I don't want to actually have like 100 or 90 or whatnot indexes. That's proximity threshold, how much together they can be, how close. Appearances. This is kind of for like individual, like, oh, I've seen this guy, it's probably this guy. This one I haven't messed with it. I haven't messed with these yet. Some things like the GMC method, I just needed to make the system work. A couple of things, I guess that's how a lot of things work. I think that's about everything I wanted to cover, because you've seen this, put text, top left, bottom right. Figure that out. This is how we get the actual confidence score. So from our results, let's work from the bottom. So yeah, we assume track ID, that's the ID of the current section, we get its ID. Then from here, get the index that add our track ID from our track IDs, get our confidence value from our boxes, and we print that results. And it's like a big decimal number, so we just want to get it to the 100th place. Anything more specific with that, that's crazy. Okay, we've said a lot of things. Let's go to model training, and then we're gonna actually run it, and you can actually visualize and see things here. So here we have our data loader. This is code on just to load in our data set. So I've used a already kind of cleaned up and pre-labeled data set, because for image detection and YOLO image detection specifically, what you have to do is you have to draw bounding boxes on each picture you want the model to train on, and classify it, which is kind of time intensive, right? I just kind of didn't want to, and then I'd have to find a good way to get all the images I want to train it and send that value. So I just went on Kaggle, found a data set I liked, and I downloaded it. So this is all just load in the particularly. I just think the context was much better here. So this is an IPYND file. It's ran on Python. It's just a cheaper notebook. Really handy for whenever you're working with models and like training a model. And also this is really handy because I can use it on Google Colab. And since I'm a student, I have access to some of the pro account things, and one of which includes I can use their GPU. So I can just run this code on the GPU and train a model on the GPU, which significantly reduces time. I ended up training this model in like 30 minutes, and I think if I trained it on my actual laptop, it'd probably take 2 days. I don't know. I don't actually know. I can't remember how many specific images are in the data set here. But it would take a while, and I really did not even expect the code. I was kind of shocked. But yeah, I have access to some pretty good GPUs through a student account, so that is a big reason why. But you can see here's where I'm actually loading the Kaggle data set. You see the name, and it already has it split up into the images and the actual labels. So those are the number of values where it's going to be class 0, which is player, and it's going to give you where the pixels are, the pixel boundary box, and tell you that's that class 0. You have to do it for all those. You see, we split that up. It's split up into train and validation already, so I didn't have to do anything intense for that. See it. So in this set, they have player, referee, and ball labeled, which one of the few ones I like that. Some of the other ones I saw a separated goalkeeper, which I'm not really fond of. I just think the more human people it splits up could be harder for the model. And I don't really have a reason to separate the goalkeeper. If anything, it would make it maybe harder if one of the teams. I don't know. I just didn't see a reason to add that, so I just thought it'd be harder. So I like that this is player referee ball. Then yeah, we just have to save the configuration and data YAML file. And here's just, again, this is just, I just pull numbers, and this is the first train. I just need to quickly train the model, plug in data YAML, 100 epics, 60 batches, which is kind of a lot. I mean, it's a decent amount. Definitely, I don't think I would have trained it on my computer on that, because it would take a while. Device 0, that's how you indicate to use a GPU. So even if I ran this file currently, not only would it, I guess, run slow, but it wouldn't run at all, because Intel does not have a GPU. They have an iGPU, which is like the GPU is built right on the CPU. So that's why I really have to use the OpenVINO to optimize things, because I literally don't even have a GPU on my computer. Let's go run the file. What we have to do is we have to actually get into our new folder. So this is in the player tracker folder, and then we just have to run our runner. So right now, setup is pulling up here. See, it's got the images. We're just not gonna mess with it. We're gonna let everything run as God, aka I intended. Okay. So I just hit enter here, and now this is it. See, kind of gets messy with all the confidence levels, but you can see 87% confident, 83, and all the IDs. Oh man, maybe I shouldn't. I just realized now, maybe I shouldn't do lime green. It's kind of blends in the field. Whoops, but you can see like 1, 2 is over here, 3, blah 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 blah, all these IDs through 14. So most of the people in there. Let's see, what are we running? Let's run the speed at let's do half speed and see how well it records, because it's not great at tracking with fast movement. That's gonna be the biggest thing. So that's more of my problem right now than inclusion is the blur and the fast pixel movements. So definitely something I'm gonna have to work on too. You can see it's a little brighter on the screen. Right, left is literally what it's recording. It's even like media player and stuff is still there. But on the right, you can see it's brighter than the left, and that's because I put it in there to help better differentiate things. I've seen it just do better. Alright, so we're gonna play this, and we're gonna let the product run. Oh my god, it's frozen. There we go. And now we're off. You can see it's relatively doing well keeping, but it's struggling. Yeah, it looks like it's a short process. It just dropped everyone there. The numbers. Okay, it still 9 and 7. That's good. These guys are still numbers. You see, sometimes it kind of drops. So that's probably something we need to train the model on to see different angles of players. Maybe this was just some angles not included in these frame shots. But one thing is I like to see how much the confidence changes. If these guys are running too, it kind of changes a lot. Again, if these things processing speed, you can look at the left, it's going pretty slow. You can see how much is behind through there. It's like 2 seconds, which is actually kind of ideal if I would want to run this on like live video. I'd pause it. But you can see it keeps dropping. Like, I remember it started like 1 through 14. Now we're at like 400 level. Now everyone's going to switch because of this. Yeah, everyone's going to be upgraded. So. But you can kind of see ideally what's happening here. I'm going to pause the video. Let's see if it changes anything. Let's see, still. So it looks like this player right now, I need to probably change the numbers. It looks like it's seeing 2 different players. So great. It looks like the same here. It's 2 different players here. So those are the things I have to work on is the image detection. And that's a good thing about using like a custom bot sort for like the tracking too. Is just I can kind of tweak that. But yeah, this is the new edition. This is a player tracker and adding some machine learning. It's cool machine learning at that with image detection here in the project. So let me know in the comments if you have any questions or any suggestions of upgrading or anything you would like to see, any good ideas I should add to this project. That's all for today. Thank you.